Welcome to the Health of Young Stand Symposium. This two-part talk briefly outlines the primary abiotic and biotic forest health factors affecting young stands in British Columbia, highlights the need for long-term monitoring data that is required to mitigate current and emerging forest health factors, and discusses the potential negative consequences of not amending government policies that drive forest management. British Columbia prides itself on being a world leader in sustainable forest management, and since the province's reforestation programs began in the 1930s, close to 8 billion trees have been planted. BC uses a mix of over 20 different native tree species in its reforestation programs, with the intent to establish resilient and diverse forests for the future, and to maintain and restore proper ecosystem function. As highlighted in this symposium, there are more young stands on the land base than ever before, and considering the challenges we are facing in light of climate change, the impacts of native forest health factors, which include abiotic and biotic factors, on young stands are becoming increasingly important. There are a host of forest health factors that can impact stand establishment and stand productivity with respect to timber volume and timber quality, and it's important to recognize that the extent of impact across the land base differs significantly, and only select factors will result in mortality or significant decreases in yield. Additionally, the frequency and extent to which various forest health factors occur can vary dramatically. However, it's important to note that although a single forest health factor may not result in mortality, the cumulative sum of different factors can significantly impact stand establishment and productivity at both a stand and landscape level. I am Babita Bains, and I will briefly outline select abiotic forest health factors and introduce select insect pests of young stands. Although there are a host of abiotic forest health factors that cause tree mortality and impact both wood volume and quality, I'll only summarize some of the more prevalent factors that impact stand establishment. David Rusch, who is the regional pathologist in the Cariboo, will provide an overview of the major diseases that impact young stands and also discuss some of the management challenges in managing young stand health. Climate-mediated disturbances are one of the greatest threats to young stands. Increasing temperatures and changing precipitation regimes will and have had adverse impacts on host tree vigor, but has also increased pest success. However, the greatest impacts to stand establishment most recently and in the future will likely be the result of landscape-level disturbances such as wildfire, which has the ability to cause extensive mortality. For example, approximately 2 million hectares were burned over 2017 and 2018. And in the photos on this slide, they're from the Plateau Complex wildfire that burned over 540,000 hectares in 2017 across the Chilcotin Plateau. Catastrophic disturbances, such as the Plateau Fire, in the interior of the province will not only result in economical losses from losing regeneration and other silvicultural investments, but also impact future timber supply and carbon sequestration. Considering anticipated increases in frequency and intensity of these catastrophic events, with a warming climate and changes to precip patterns, landscape-level forest management and landscape-level wildfire management, which goes beyond community or interface fuel management, are extremely important as a means to mitigate wildfire-related losses to our silvicultural investments and also to mitigate ecological and community impacts. Additionally, forest health factors that have historically not been an issue may become pests as we see changes in climate and host vigor. Typically innocuous pests such as black army cutworm or secondary pests are and could become agents of tree mortality in predisposed stands. For example, black army cutworm, which has generally not been a common pest of recently planted stands since the 1980s, back when prescribed burning was broadly used for site preparation. However, following recent landscape level wildfire events and higher intensity wildfires, the cutworm has caused low incidence mortality and also has had broader impacts on productivity at a site or stand level. And that's essentially from defoliation of seedlings or the requirement of replanting any killed stock. Although the impacts are generally not extensive, consideration of the risk and hazard of this pest is important to minimize losses to regen investments in recently burned areas. In many parts of the province, drought has become one of the most limiting factors for tree species establishment. Drought has and will continue to be one of the leading causes of young stand mortality related to a warming climate, but drought will also result in growth reduction at the stand level due to induced carbon starvation. Select species are more susceptible to drought stress, for example, western red cedar on the coast, and generally younger or suppressed stands are more susceptible to succumbing to drought-related mortality, especially if there is a predisposing factor such as lodgepole pine dwarf mistletoe, as we see in the caribou, or hemlock dwarf mistletoe, like we see on the coast. Additionally, drought stress, especially cumulative stress or back-to-back years of drought, not only reduce host vigor and increase susceptibility to other forest health factors, such as defoliators or bark beetles, but typically innocuous pests such as secondary bark beetles are becoming agents of tree mortality in these stress stands. Although frost does not impact young stands to the extent that drought or wildfire does, the stand level impacts in regenerating Douglas fir on cleared areas due to frequent summer frosts are significant throughout the Cariboo-Chilcotin. Summer frosts throughout this region are a significant factor in reducing initial stand establishment and growth of planted Douglas fir, and highlights the importance of implementing silvicultural tools that can be employed to minimize adverse effects to establishing stands. Additionally, late spring frost can result in frost heaving, which typically occurs in high elevation stands or site prepped areas where mounding is used, and these frost events can lead to seedling mortality at a stand level. From a management perspective, it's important to understand which sites are susceptible to drought or frost events and develop strategies, including species selection to minimize impacts on newly established plantation and young stands. The use of tools such as the climate-based seed transfer and CCISS applications for species selection, plus timing of planting, in addition to microsite selection, are some of the tools we can use to mitigate drought and frost impacts. Lorraine McLaughlin and Vanessa Ford discuss these drought impacts and the effects of climate change in their presentation on drought and climate impacts, young stand health and mitigation strategies in session 3 of this symposium. Heavy snowfall and hail can also cause mortality or growth losses when foliage and or buds are removed, and also cause deformities which affect wood quality. Impacts from snowpress and hail typically occur in patches or are scattered throughout plantations. Now I'm going to summarize select biotic forest health factors, which include a few of the more prevalent insect pests of young stands, and I'll start with mountain pine beetle. As most of you are well aware, the mountain pine beetle outbreak started in the early 1990s and affected more than 18 million hectares of forest. Typically, mature pine or stands greater than 50 years old or larger diameter trees are attacked by mountain pine beetle. However, during the unprecedented outbreak, young pine stands or smaller diameter stands were also impacted throughout the province, but primarily in the central interior. I've provided a brief summary of results from a study completed by McLaughlin in 2006 that illustrated stands as young as 20 years old were being successfully attacked. This outbreak had significant landscape level impacts on young stands and our midterm timber supply, and it's been estimated that the AAC will drop by approximately 12.5 million cubic meters from the pre-pine beetle AAC, and that these shortfalls will last up to 50 years. Although we do not anticipate an outbreak of the same magnitude to occur in the near future, we do anticipate future impacts to young stands with future outbreaks, and our best option to mitigate the impacts is to manage pine stocking on the land base, but to also use planning tools such as CBST and CCISS to ensure adequate species selection is done in silviculture planning. Additionally, past and potential future impacts highlight the importance or need for inventory data to be collected at layers below the canopy level. Terminal weevils are found on pine and spruce throughout most regions of the province. Although they generally don't cause tree mortality, they do impact timber volume and wood quality by causing stem deformation and height loss. Stem deformation occurs when lateral branches below an attacked leader compete for dominance, causing a forked or dwarfed tree form. Repeated attacks on new dominant laterals will cause severe stem deformation over time, and we anticipate that young stand pests such as spruce weevil or lodgepole pine terminal weevil, incidence and impact will continue to increase due to increased host stress as a result of frequent drought events. Efforts to mitigate weevil impacts have focused on risk assessment and reduction, and this can be further facilitated by planting mixed stands or alternate species in high hazard areas, by increasing stand density, and also through the use of resistant seed, which is available for Sitka spruce on the coast. An additional tool which is not commonly used is shading of planted region in high hazard areas. Warren's root collar weevil can also be a pest of lodgepole pine and spruce, and typically in stands that are mixed with pine and less frequently of Sitka spruce on the coast. Weevil attacks are most evident on 5 to 20-year-old trees or young plantations with small diameter trees. Severely affected trees of this age class exhibit above ground growth reduction, decreased root diameter growth, and occasionally mortality. Warren's root collar weevils can live up to 5 years, and this longevity is a concern during the regeneration of host trees. A planting delay of 2 to 3 years in areas where large pre-harvest weevil populations are present may reduce the impact on susceptible stands. Prescribed burning was used in the past, and an alternate for that method would be site prep to reduce the duff layer and an increase in planting density. Several different mammal species damage a variety of conifer hosts at both the seedling and sapling stages. Damage can occur from porcupines, deer, cattle, bears, and voles, and the impacts of mammals will vary by region, stand, and site. For example, on the coast, western red cedar seedlings are particularly susceptible to browsing by black-tailed deer and elk, especially on Haida Gwaii where there are no predators of the deer, and damage across a block may vary. And in the Caribou and Thompson Okanagan regions, seedlings and saplings can both be browsed if fodder is limited or trampled when seedlings are not planted next to obstacles. To mitigate damage from animals, it's important to understand the local risks and what can be done to minimize losses or impacts. I'll now turn the mic over to David.
My name is David Rusch, and I'm going to finish up part one talking a little bit about forest diseases. And then I'll finish with a discussion of some of the major management risks to young stands. Root diseases are some of the most challenging and damaging diseases of young stands. Armillaria root disease, laminated root disease, and black stain root disease occur in southern British Columbia and are important root diseases. Tomatosis root disease occurs throughout British Columbia, but is especially important in the north. This slide shows the armillaria severity distribution in the Thompson Okanagan ICH, and this is for fur-leading stands. So about 20% of the stands had no detectable armillaria. Another 20% had 0.1 to 2.5% armillaria. 40% had 2.5 to 15% armillaria, and 20% of the stands actually had more than 15% of the trees affected with armillaria. So pretty significant numbers. Silviculture issues. Normal forest management can result in higher levels of root disease over time. In addition to this, good impact data is lacking for many parts of the province. Because root diseases are diseases of the site for the most part, good pre-harvest data is essential for effective management and monitoring, and data is often not collected. It's difficult to survey for root diseases, and they're often missed in results in young stand monitoring surveys. As an example, laminated root rot is common in the southern interior of BC, but if you do a search in results for laminated root rot, it doesn't really show up for the most part. It's difficult to set standards for prescribing and carrying out stumping treatments under professional reliance. It's a good idea to delay free growing declarations until 15 years of age. This allows the root disease to be adequately expressed in high hazard root disease areas. As a result of climate change, we could see more black stain and more severe armillaria in the future. And root diseases often occur together where their distributions overlap. Next up, we're going to talk about stem rusts and cankers. Major stem rusts and cankers. White pine blister rust is an introduced disease from Europe that was introduced around the turn of the century and had a devastating effect on the distribution of white pine in the province. Commander rust, stalactiform rust, and gall rust are three common rusts of lodgepole pine stands. And Atripel's canker is not a stem rust, but I've thrown it in here with the stem rust. It doesn't have an alternate species, and it's very common in high-density lodgepole pine stands. This next slide shows the amount of stem rust in 10 of the most impacted resource districts in the province by rust severity. The data is modified from Rusch 2010 from results data. Stem rust silviculture issues. As with the root diseases, free-growing declarations and pre-commercial thinning in stands less than 15 years should be avoided in order to allow stem rust to be fully expressed before the stand is declared. Trees with commander rust stem cankers or branch cankers close to the main stem have a high rate of mortality, which can lead to openings and low stalking. Warmer and wetter weather in northern BC may be resulting in more frequent wave years and higher incidences of stem rust. Lodgepole pine stem rusts often occur together. Alternate hosts or infected pine in and around nurseries can serve as infection sources for planting stock, and this is sometimes an issue because planting stock from the nursery is sometimes infected with stem rust before it's even planted. There are gall rust resistant families, but they're in fairly short supply at the present time. Okay, moving on to dwarf mistletoes. We currently have 4 species of dwarf mistletoe in the province. Lodgepole pine and hemlock dwarf mistletoe are the major ones, but we also have some larch and Douglas fir dwarf mistletoe in the southern parts of the province as well. This slide shows the incidence of lodgepole pine dwarf mistletoe in the Caribou and in Merritt. And the bottom portion of the slide shows the dwarf mistletoe rating for those young stand trees. And this next slide is based on some modeling projections that were made based off of young stand monitoring data. This is with dwarf mistletoe turned on in prognosis and with dwarf mistletoe turned off. And you can see the percent change in merchantal volume with increasing rotation age. So this is one of the good examples where we've been able to use the incidence and severity of a current forest health problem to project future impacts using modeling. Silviculture issues with dwarf mistletoes. There's inconsistency throughout the province in how dwarf mistletoe sanitation treatments are carried out. Recent sanitation research suggests that for lodgepole pine dwarf mistletoe, it may not be necessary to sanitize trees below 2 meters in height. There are multiple ways to record dwarf mistletoe sanitation treatments and results, and this can make it very difficult to track. Many BCTS sales do not specify a knockdown rule for dwarf mistletoe residuals, and this can result in increased silviculture costs when trying to deal with dwarf mistletoe. There's often a lack of stratification pre-harvest for post-harvest sanitation treatments. It can be difficult to stratify blocks post-harvest, especially in areas where there aren't a lot of tall lodgepole pine residuals left after harvest. In recent years, we've been dealing with a lot of the lodgepole pine, mountain pine beetle leftover blocks, and a lot of these blocks often are long and narrow and have a lot of infected edge, which is not ideal for dwarf mistletoe management. And knockdown on road right-of-ways or existing trails has been a big problem throughout the province. Um, Trees are often left in these road right-of-ways and in trails. And these two pictures on this slide are a good demonstration of that. We have infected dwarf mistletoe trees left along road right-of-ways that are then infecting the adjacent young stands. Okay, moving on to foliage diseases. This is a problem that could become a lot more important with climate change. I've highlighted some of the major foliage diseases in the province. Uh, some of the major foliage diseases on lodgepole pine are Dothostroma, Elytroderma needlecast, and Lophodermella needlecast. And in recent years, we've seen a big increase in Swiss needlecast. It wasn't really a big problem in BC in the past. It was more of an Oregon issue, Oregon-Washington issue. But in recent years, we've seen a big increases in the amount of Swiss needlecast. And finally, larch needle blight and cedar leaf blight. Silviculture issues. It's difficult to monitor foliage diseases using aerial overview survey, young stand monitoring, or results data. It often requires specialized monitoring plots or a spring aerial mapping surveys. Many foliage diseases require similar conditions for outbreaks to happen, and so we often see um, more than one foliage disease occurring at a time. We've seen increases in Swiss needlecast on the coast as a result of climate change, and it was also likely a factor in Dothostroma outbreaks in northwestern BC. We've also had an issue in the southern Cariboo where mixed Douglas fir and lodgepole pine stands are clear cut, planted back to lodgepole pine, and then these stands become heavily infected with Elytroderma needlecast. And it's very difficult to get Douglas fir back on many of these sites because of the frost risk. We're seeing larch being planted in increasing numbers. It is a very fast growing species, so it's good. It has similar to lodgepole pine in that it can be a good strategy for getting your stands free to grow sooner. We're not too sure how larch needle disease will respond to the increased planting of larch. One, trees show a high degree of uh, variation resistance to foliage disease, so this is possibly one technique we could use in the future, screening for foliage diseases, but it will require uh, research funding to develop inoculation techniques for screening of families. The second part of our talk deals with other management threats to the health of young stands. We need to have good forest health monitoring and treatment data in order to ensure the future health of young stands. It needs to be reliable, summarized in a useful way, and be accessible to multiple users. Climate change is by far the biggest challenge that we face to our young stands moving forward. We need pre-harvest forest health information for evaluating some forest health treatments. I mentioned root disease earlier and the need to have pre-harvest root disease information. We need landscape level planning to address future forest health. We need to be cognizant of unintended consequences of free growing and other government policies or behavior. It's often the interaction between government policy and licensee costs and revenues that become the real motivators or drivers for licensee behavior. And it's currently difficult to determine how young stand health relates to impacts at rotation. Lack of good summarized monitoring data. And it's difficult to know if forest policy is encouraging proactive silviculture decision when it comes to mitigating future and current forest health risks. How is it that we're monitoring these outcomes? Do stalking standards adequately address future forest health risks? There was a recent Forest Practices Board reforestation in the IDF report in 2020, and a quote from that is, "There are no formal reporting mechanisms in place to assess whether provincial goals and management unit objectives and targets for species composition and longer-term stalking are being met." How do we know whether stalking standards approved in a forest stewardship plan are addressing forest health risks at the site level? Is results data an accurate reflection of the health of our forests? And how will past and present silviculture decisions affect the health of our future forests? Climate change is quickly emerging as the biggest threat to the health of our young stands. Bavita spoke eloquently about fire and drought earlier. Uh, it's kind of irrelevant whether trees have dwarf mistletoe if they're being killed by drought and fire. There's also an important interaction between environment, biotic forest health factors in trees, and changes in the environment can drastically shift the balance between trees and their biotic forest health factors, which generally have much shorter uh, generation times. This is a picture of a dwarf mistletoe long-term trial that was set up just prior to the 2017 fires. So it's often difficult to make good silviculture decisions if you don't have good pre-harvest data, and this is true of the root diseases and for dwarf mistletoe as well. And another issue I'll just mention briefly is this: we have this artificial separation between harvesting, layout, and planning, and silviculture. And this causes a lot of problems because in order to do a good job in silviculture, there needs to be a connection between the harvesting side and the silviculture side. And I don't think I need to explain that these two are integrally linked. Are we adequately mitigating for future forest health and climate change risks by planting a diversity of species either at the landscape or the block level, and by managing for uneven age class distribution post mountain pine beetle? Things like landscape level tree species decisions, developing markets for small dimensional wood products, uh, and using intensive silviculture to get bigger wood sooner to even out age class and size distribution over time. One of the impacts of mountain pine beetle is we have a lot of young lodgepole pine stands that are all in the same age class, and this will become really important in the future as these stands mature. Effects of forest policy. Sometimes there's unintended consequences of government policy. An example would be some of the effects of free growing policy on overplanting of lodgepole pine, and uh, sometimes stands are declared before root disease or stem rusts have time to be fully expressed. Um, How will increased pressure for free growing surveys using drones affect future forest health assessments? Right now, forest health damage criteria, one of the few ways that we have to ensure licensees are accounting for forest health in their silviculture treatments. Are forest health requirements for forest stewardship plans adequate? Uh, Are free growing requirements and stocking standards enough to ensure the health of our young stands? It's often difficult to enforce preconditions or treatment methods under a professional reliance framework, and I discussed this a little bit in talking about some of the issues around stumping. How does incidence in young stands relate to impact at rotation? So unfortunately for forest health people, um, TAS TIPSY models are based on a perfect world without forest health. So this means that we need to add in fudge factors to account for the real world and forest health that occurs in that real world. For most forest health factors, we don't know what the effect of current levels of disease will be on volume or wood quality at rotation. And what we use instead are defaults that don't account for forest health because we don't have any better information. We need to develop impact models for each factor separately, and at the present time we only have one or two models that address this issue. For root disease, harvest decisions can mean increased operational adjustment factors over time. So um, people don't harvest stands randomly. So this means that your root disease OAF is probably going to increase over time because higher volume healthy stands are going to be harvested first. And this is just uh, the nature of our economic system and our tenuring system. That's it for our talk. Thanks very much for listening, and I hope you enjoy the rest of the presentations. Bye for now.